Now we're going to talk about translation and reflection of functions. To start off, let's talk about what we mean when we talk about translating and reflecting functions or graphs. In this slide, we've taken the graph of the function y is equal to x squared, and we've manipulated it a bit. On the right-hand side here, the solid line represents the function of y is equal to x squared. On the left, we see that we have something that looks like x squared. It has the same shape, dimensions, and proportionality, but it's been shifted from 0 to 1 on the y-axis. And that's what translation means. We're basically picking up a function or a graph, and we're moving it around. Reflection, on the other hand, is just what it sounds like, and you can see from the right here that the dashed line looks just like the function x squared above it, but it's almost as if someone has mirrored it around the x-axis. Let's say that the 0 here represents the top of your head, and your eyes are facing in the positive y direction. The solid line would be the mirror image of the dotted line on your side of the mirror. And you can reflect graphs or functions around different parts of the xy plane. In this case, if you reflected it around the y-axis, you'd basically get the same thing since it's symmetrical with the y-axis. It's not, however, symmetrical with the x-axis, because if you took the dotted line away, you wouldn't have any part of the function y is equal to x squared represented on the negative y. We're going to go over a few rules and examples, and I think you'll find this isn't very hard once you get the hang of it. And these types of questions are usually very popular for quizzes and exams, so it's a good idea to know them. Let's first take a look at the graph on the right-hand side here. You have a blue line going through the origin, or 0, which represents y is equal to x, which makes sense, because when x equals negative 1 here, so does y. When x equals positive 1, y also equals positive 1. And then of course when x is equal to 0, y is also equal to 0. So now that we pointed out the function y is equal to x, let's talk about how to translate this function. That is, move it around the xy plane. Just as there are 4 quadrants to the Cartesian coordinate system, when it comes to translating functions and graphs, there are 4 different directions you can translate them, so that makes it easy to remember. Let's go over translating up, down, right, and left in that order. When we wish to translate a function or a graph up, we take the function and add to that function some constant. So the function we started out with is f of x is equal to x. If we want to translate that 1 unit upward, we could write f of x is equal to x plus 1. And if we do that, you can see that for any point on x plus 1, it's just shifted up by 1 unit. For example, on the graph y is equal to x, when x is equal to 0, so is y. But on x plus 1, when x is equal to 0, y is equal to positive 1, and not 0. Likewise, on y is equal to x, when x is equal to positive 1, y is equal to 1. But on the graph of y is equal to x plus 1, when x equals positive 1, y is equal to positive 2. So for every value of x, the y value has been shifted up by positive 1. Now let's talk about how to shift graphs downward. This is easy to remember because it's just the opposite of shifting them upwards. So if you want to shift it down by 1 unit, you would subtract a 1 instead of adding it. And we can see that here for f of x is equal to x minus 1. Let's do the same thing and take a look at our base graph, which is y is equal to x. We said before that when x is equal to 0, so is y. On the graph of y is equal to x minus 1, however, when x is equal to 0, y is equal to negative 1. And you can keep going in either direction by adding or subtracting units from the function. So for y is equal to x minus 2, when x is equal to 0, y is equal to negative 2. For the function y is equal to x plus 2, when x is equal to 0, y is equal to positive 2. So now we've gone over upward and downward shifts. So what I would say is that if you think of f of x as being equal to y, then you're shifting up or down. And so we were just looking at lines. But just to show you, this works the same for higher order functions, meaning functions where the variable x has an exponent greater than 1. As you can see on the left-hand side here, we have the function of y is equal to x squared. To the right of that, if we take the function f of x, which is equal to x squared, and add the constant of 1 to it, that shifts it up on the y-axis by 1 unit. Likewise, we have the function y is equal to x squared, but we've subtracted a constant of 1 from it. So that shifts it down on the y-axis by 1 unit. And as we said before, you can add or subtract additional units to shift it further. We have the base function of y is equal to x squared on the left here, and to the right of that, we've now shifted it downward by 2 units instead of 1. So we've just been talking about translating functions up or down. Let's take a break here. When we come back, we'll talk about how to translate or shift functions from left to right.